Do you see that? A piece of the sun has actually broken off, and it's now spinning above the surface, forming a massive, glowing vortex. What's happening up there? Let's admit it. Despite how vital the sun is to our existence, we still understand very little about it. But when it comes to this strange event, scientists do have some clues. Most likely, a portion of the sun's plasma erupted from the surface and detached, forming what looks like a swirling crown above the solar North Pole. Still, that's just a working theory. Astronomers are digging deeper because nothing like this has ever been recorded before. The footage? Stunning. But the implications? Potentially serious. Because here's the truth, the sun is changing. Right now, it's ramping up activity, throwing out flares, forming new sunspots, and behaving more chaotically than usual. So far in 2023, it's flared every single day. Even more concerning, we've seen multiple X-class and M-class flares this January, the two strongest classes of solar eruptions. Should we be alarmed? Not quite. The sun follows an 11-year activity cycle. Some cycles are calm, others are downright violent. These cycles occur alongside the weakening and flipping of the sun's magnetic field. When the magnetic strength at the poles drops to its lowest, the polarity reverses, and that's when the sun reaches peak activity, a period called the solar maximum. Right now, we're closing in on that maximum. Scientists estimate the reversal could occur around July 2025, based on current activity patterns. But here's the tricky part. Each solar cycle is different. Some are mild, some more extreme. The current cycle, which began in December 2019, has already blown past initial predictions, and it's still intensifying. Which brings us back to the unusual vortex observed on February 2, 2023. It started as a solar prominence, a bright, looping filament of plasma extending from the sun's surface. These are fairly common and often form in the corona, the sun's outer atmosphere. They can resemble hedges in shape, which is why some are called hydrominances. But this event took an unexpected turn. The prominence didn't simply fall back or dissipate. Instead, it detached and began rotating near the solar North Pole at about 60 degrees latitude, spinning at 60 meters per second, and lasting nearly 8 hours. One solar expert, who's observed cycles for decades, admitted he's never seen anything like it. Unfortunately, studying the sun's poles is extremely difficult. They're rarely visible in detail. But there's hope. In 2021, NASA's Parker Solar Probe made history, becoming the first spacecraft to enter the sun's atmosphere. It gathered data on magnetic fields and particles, bringing us closer than ever to understanding how our star works. One major discovery? The probe detected strange zigzagging magnetic structures called switchbacks in the solar wind, those fast streams of charged particles constantly flowing from the sun. For years, scientists didn't know how or where they formed. Now we know. They originate right at the solar surface. Now remember, the sun doesn't have a solid surface like Earth. Its atmosphere is made of extremely hot, electrically charged material shaped by magnetic forces and gravity. As this material heats up, pressure builds and pushes it outward. Eventually, it crosses a point of no return, where neither the sun's gravity nor magnetic pull can hold it back. This invisible boundary is called the Alfvén critical surface. Once material crosses it, it becomes solar wind, dragging the sun's magnetic field far into space. Past that point, solar wind moves so fast that any wave traveling within it can't return to the sun, effectively severing all connection. During its journey, the Parker probe crossed this boundary multiple times, showing that the edge of the solar atmosphere isn't smooth, it's spiked and warped. At one point, it even passed through a pseudo-streamer, an enormous structure visible from Earth during eclipses. Inside, the environment was unexpectedly calm. Fewer switchbacks, slower particles, like flying into the eye of a storm. Now let's talk about solar flares and why they matter. These explosions release intense radiation that can interfere with our technology. Radio communications, GPS, internet, satellites, all at risk. Most flares last a few minutes, but the strongest ones can go on for hours. Solar flares are classified by how powerful they are in X-rays. Small ones are barely noticeable without special instruments. Medium ones may briefly disrupt radio signals near the poles. But X-class flares are the real concern. They can trigger major solar storms that knock out systems across the globe. If a powerful solar storm were heading our way, it would unfold in stages. First, a burst of ultraviolet and X-ray light would ionize Earth's upper atmosphere, disrupting radio waves. Next comes a radiation storm, followed by a massive cloud of charged particles that slams into Earth's magnetic field. That's when the real chaos begins. Satellites could be disabled, GPS would go haywire, communication systems could fail. Astronauts outside the ISS would have only minutes to seek shelter. Even on Earth, power grids would be vulnerable. The resulting surges could fry transformers and cause blackouts on a global scale, with damage estimated between $1 trillion and $2 trillion. The good news? We're watching, constantly. Modern solar observatories and satellites track the sun 24/7. If a giant flare was on its way, we'd likely have several hours to a few days to prepare. If systems are shut down in time, especially transformers, we could avoid the worst. That's it for today. If this blew your mind, give the video a like and share it with friends. After all, the sun might be 93 million miles away, but its next move could change everything.